Welcome to graphing quadratic functions. Quadratic comes from the term quadratus, which is Latin for square. Quadratic function is a function in which the greatest power is 2, so you're squaring the exponent. As a result, you can have one of two types of results when you graph it. You can have a parabola either facing downward if it's negative, or upward if the exponent is positive. Notice for both of these, though, it doesn't create a V. There's no sharp edge. This slides around. It's more of a U shape as opposed to a V shape. Should be no angle at the end. So I'm going to show you three examples of a quadratic function. Here's the simplest one you'll probably ever see, y equals x squared. Okay, first step I'm going to do is create my chart. I have my x column, my y column, and then my ordered pair xy column. That's where I'm just going to join these two values together in an ordered pair. Now, unlike a linear function where you could get away with just 3 inputs, I would go with 5 for a quadratic function. I would go with a negative and a positive of each of the terms, and you'll see why in just a moment. So here's my information for my y column. There's my ordered pairs. Now notice when you square the x, the y, both the negative and the positive are going to be the same. So this is going to give you that parabola shape on your graph. So here 0, 1, 4, going the other way 0, 1, 4. So here's my graph. I'll go ahead and plot my points. There they are plotted, negative 2, 4, there's 2, 4, negative 1, 1, 1, 1, and 0, 0. And here's my parabola. It's coming down. Notice again there is no V point here, and going back up, so it's a smooth line. And notice also that this is symmetrical. It's going to be symmetrical along the y-axis, at least for this one. When you get to higher levels of math, it might shift off the y-axis, but for now it's pretty much going to be along the y-axis just for us. Here's a second type of example. This time we have a negative number. Here we have our chart. Notice that instead of y we have f of x, but we're going to still treat this the same way as if this were y instead of f of x. I went ahead and filled in the chart. Notice that negative 2 for the input is negative 8, the same as if it were a positive 2, negative 8. There are my plots pointed. Notice this time that the points are facing down, and that's going to make a difference, of course, when we graph it, because it's going to face down. Again, this point here is not this V-looking shape, but it's going to be a smooth shape, even if it's really close to the y-axis here. There's still going to be a little bit of a smooth little bump there. Okay, let's look at one final example that you may see in the book. Okay, we're dealing again with x and y. I've inputted some numbers for my x column. Here's my y input for negative 2 and 2, negative 1 and 1, and lastly 0. Okay, I've organized my ordered pairs here. And notice this time the 0 coordinate for x does not pass through the origin. It's slightly off the origin. It's 0, 1 this time. It's because we added 1 up here. There's our parabola. And this one's facing up again because we don't have a negative number associated with our variable there. So that's why it faces up. If we had a negative number here, it would face in downward. So things to remember for a quadratic function. For a quadratic function, you're graphing a parabola. It's not a straight line. And also pick your x values wisely. You don't want to pick numbers that are too big and it's difficult to graph the numbers. Now your parabolas, sketch them the best you can. It's not as easy to do as linear functions because there's a little bit of interpretation for them. But they should go through those points that you graph on the coordinate plane.